All right, Year 11. It occurred to me after a couple of students stayed back at the end of class that those exact values that I referred to in the starter questions and then referred to in my lesson, not many of you have seen those before. So I assumed incorrectly that was that had been learnt somewhere along the line in probably last year, and that it was just a refresh. So I apologise for that. So I'm going to go over the exact values now. So I'm going to go over these exact trig values now because they are so important to our work in trigonometry in this unit and in other units. So I really want you to know where these are coming from. So they're called exact trig values because we're going without a calculator. I'll show, and they refer to just really just three angles to start with here, and they emerge from two triangles. Right? One is the isosceles right angle triangle, which I'm building now. Which isosceles right angle triangle, it doesn't have to have 1, 1, root 2, but in its simplest form, it's a 1, 1, root 2 triangle. And what that teases out for us is this angle in here, the 45 degree, or the pi on 4 45 degree angle in here, and obviously the 45 degree angle there as well. That's one triangle, so we can use SOHCAHTOA now to get sine, cos, and tan of 45 without resorting to the calculator. So this is a paper 1 type scenario where you need to find manually a trig value, all right, and it'll come out of these angles. But the other one, the other two angles actually come out of the equilateral triangle that starts off life as a 2, 2, 2. This is one I referred to in class, and I'm so pleased that I had a couple of you stick around after the class to say, what was that thing? All right, so what we do is we split the 2, 2, 2 in half, and it becomes that 2 becomes, so these are now, what I've done is dropped a perpendicular down here. We have 60 degrees in here, and obviously 60 over here as well. And now, because I've got equilateral triangles, congruent triangles, here I've got two congruent triangles, which I know from what can I say? How can I prove it? I've dropped a perpendicular down here, so I've got side, right angle, hypotenuse, side to prove that they're two congruent triangles, and as they're congruent, they are that splits the base into two ones, and it splits this angle into 2/30s. Okay, now we're only concerned with one of these, so we can remove half of this triangle. So this is the half we use, just there. Okay, so there it is. And now using Pythagoras, we can work out the height here, which is root 3. And now from this, we have our what we refer to as our exact trig values. So we don't need to memorize these. We just need to be able to construct these two triangles. So if you just get a little practice at drawing these, when you're doing a paper that's going to use these values, I always find investing 15 seconds in drawing these two triangles up means you're not using up working memory space with memorizing, and quite often incorrectly memorizing exact values, when you can just lean on the isosceles right angled and the half and equilateral triangle, because they bring out the 30, 60 and 45s that you need. And the way I remember these is I just have a visual of these triangles. I guess when I was a student, I used to write them down all the time, but now I can just see them, and so I just sort of picture them in my mind, and I can see where the opposite and the adjacent sides are and things. So if I want, for instance, cos 30, I will access this triangle over here, and I will say cos 30, and I'll imagine, all right, my adjacent side is this one here, and my hypotenuse is over there, so it's root 3 over 2. Okay, so that's how we do that's how we find the exact values. But now that we look at the sine, cos, and tan as functions, and we're looking at outside the triangle, this now means that any angle that has 30, 45, or 60 in any quadrant is going to be an exact value for me. All right, and so we'll do some examples in a moment where you see that happening. Okay, so now we've explained how these trig values are accessed. We're going to use these a lot, right? So, but this is where they're coming from. Whenever we refer to the trig values, exact trig values, they're coming out of those two triangles, and they're referring to angles of 30, 45, and 60. Okay, so let's get back to now our unit circle and see. Let's just recap a few of the things we talked about in class. All right, so we said that I'm going to take an angle of say 30 degrees. Right, so I think that's about here. So what we looked at today was, okay, we were now referring to the coordinates here of points on the unit circle as being with reference to this angle theta here that is measured clockwise from the positive x around to the radius that connects to the point that we're interested in. So this is the point here. So if that, I'm going to use a value. I'm going to go with 30 degrees here. And I know from my exact values at 30 degrees, my cos 30 is root 3 over 2, and that's going to be my x coordinate here. So I've got root 3 over 2 as my x coordinate, and my y coordinate is sine 30. Sine 30 is 1 over 2, so half. Okay, remember that just comes out of SOHCAHTOA. Right, if I drew a little, we don't need to do this each time, but just to recap, we've got a right angle triangle sitting in here, and the x coordinate, right, remember that this is a unit circle, so that's got a radius of 1, and the x coordinate is here, and that's the adjacent side to this right angle triangle with a reference angle of 30. So cos 30 equals x over 1. So that's why root 3 over 2 is my x coordinate, and 1 over 2 is my y coordinate, because sine 30 is equal to my y coordinate over 1. So y is equal to sine 30, and sine 30 is equal to a half. So they're my coordinates for this particular angle here, 30 degrees. Now, that's not what we looked at in class today in the lesson was that what that also opens up now are angles in other quadrants. All right, so that's sine 30, or so let me put it this way, a half as a y coordinate also pops up over this side in the second as an obtuse angle here. All right, now so whatever this angle in here is, whatever that angle in there is, has got the same y coordinate as the 30 degree angle. All right, and I know over here that my coordinates are cos 150, I've given the game away, cos of this angle in here, whatever it is, and sine whatever that angle is. All right, now I know. Okay, so the symmetrical properties, what I've done is I've reflected this red line and the blue line has emerged. I've reflected in the y-axis. So what is held is this 30 degree angle in here. This 30 degree angle in here is held. Okay, so the associated acute angle in the first quadrant is there at 30. But what I find then is that therefore this angle in here is 150, and so therefore the coordinates of this point are cos 150, sine 150, because that's the definition of cos and sine. But I now can see that sine, I know what that is. I know that that's 1 over 2, that's a half, and I know that cos 150, I know the coordinates of this point because they're going to be the negative of the x coordinates for 30 degrees. So what this tells me is that sine 30 degrees is equal to a half, but so is sine 150. Sine 150 is equal to a half. It also tells me that cos 30 is equal to root 3 on 2, and that cos 150 is equal to negative root 3 on 2, because I am now in the negative x. So this value of x here is the negative. These distances here and here are equal. So I've just got the negative x coordinate that I had for 30. And so we can just keep moving around the circle in this fashion, whereby all that's changing are the sines. So this angle here in this quadrant, I'll dig out a new color. So this angle down here, this 30 degrees is maintained, because I'm now reflecting my blue radius in the x-axis. Now what doesn't change is my angle becomes 210. So my coordinates are cos 210. I know this. Sine 210. I know this because of my symmetry. But what I also know is that my x coordinate now doesn't change from cos 150. My x coordinate is negative root 3 over 2, and my y coordinate is, well, it was a half there, now it's negative a half, right? Now it becomes negative a half. So I now know that cos 210 is negative root 3 on 2, and sine 210 is negative a half. I could also, from that, determine what tan 210 is. I could do tan 210 degrees, because that's just equal to my sine, negative a half, over my cos, which is negative root 3 over 2. Multiplying top and bottom by 2, I get 1 over root 3. So I could work out from that what tan 210 is. And this is all just coming from my understanding of my exact values from SOHCAHTOA. It's also coming from our newly defined trig functions according to the angle at the center made by positive x and the radius. And so let's not leave the fourth quadrant out. We would reflect again. So we're now reflecting this sky blue, and we are going to end up over here. My 30 degrees is maintained in here. So that angle all the way around there is 330 now. So cos 330, sine 330 are my coordinates. And I know a little bit more about it. I know that my x coordinate is back to root 3 on 2. So I know that cos 330 is equal to positive root 3 on 2. And that sine 330 is now equal to negative 1/2. Okay, now that we've worked our way around the unit circle into all four quadrants, and we've seen all the angles emerge, I also want to highlight the point that whilst this is this angle down here, say 330, we could represent that as coming in a negative direction as negative 30. So there's huge adaptability and flexibility with these angles, depending on whether we're going anti-clockwise positive or clockwise negative. And also, we can go beyond the 0 to 360. We can go through a second lap. So this angle here of 30 degrees, well, it's got the same. If we came around 360 back, excuse me, and did a whole loop, we'd be back at 390. So these values here, I could say that there is equal to cos of 390 degrees. And this is equal to sine of 390 degrees. And we know there's no end. There's an infinite number of angles that we can associate with those coordinates. All right, so I just want to now look at each of the quadrants and whether sine, cos, and tan, what their sign is, whether their sign as in SIGN, whether they're positive or negative. So in this first quadrant, we have x and y both positive, and because, as we know, x is now cos and y is now sine, that means sine and cos both going to be positive, and therefore tan is going to be positive also. So all our trigonometry, all our trig functions, sine, cos, and tan, they're all positive in the first quadrant. Let's move into the second quadrant, and when we talk about labeling quadrants, this is quadrant 1, this is quadrant 2, and we go around like this, quadrant 3 and quadrant 4. Okay, so I'm going to rub those out, but when we refer to them, quadrant 1 is the positive quadrant, and then we go anti-clockwise around the same direction as the angle goes. So in the second quadrant, what's happening? X is negative, so that means cos is negative. Sine is, y is positive, so sine is still positive, but x is negative, which means tan is negative also. So in this quadrant here, only sine, and remember sine is spelt with an E, only sine is positive. In the third quadrant, we've got now x and y are both negative, so sine and cos are both negative, but tan, because it's the ratio of the two, becomes positive. So our tan function is positive in the third quadrant, and the others are negative. So what I'm doing is writing down which of our functions is positive. All in the first, only sine in the second, only tan in the third, and in the fourth, have a crack at it. What do you think it is? Right, x is positive, y is negative. So cosine is the only function that's positive in that quadrant. So when we're dealing with angles in that quadrant, cos is positive, the others are going to be negative. Now, we usually remember this, ASTC, we usually remember this by just the first letters. Right? So I'm going to now remove, so that we've just got ASTC. And when I was at school in New South Wales, it was all stations to Central, Central being the Flinders Street of Sydney. It was the main station. So get on a train in the suburbs, and the announcer would say, "This is a train that's all stations to Central." So this is New South Wales students in my day. It was all stations to Central. That was the way I remembered it initially when I first came across this concept. There are other ways, and maybe now we're at Geelong Grammar, it's all stations to Corio, perhaps, if you want to use the train. All students take calculus, I think, is another one. I think I've just seen in the textbook. Add sugar to coffee. I don't know. You guys remember it in the best way you know how. But that's an important, probably the best way to remember it is just to know which quadrant you're working in. But it is quick. It is much quicker if you're just going to be able to pull that out straight away. You know which quadrant things are positive. So if that needs to be remembered. All stations to Corio, perhaps. Okay, so now I'm just going to work through some examples with you. Great if you pause the video and work these out yourselves, or if you just want to watch it through and get the hang of it and see what's going on, that's fine too. So for each of these, I'm going to draw a really quick little number plane, and I just want to draw this angle. So what I'm being asked to find is what the value of cos 330 is. Now I don't know if I'm going to keep drawing circles on all of these, but just to reinforce the idea of what this actually means, a 330 degree angle is 30 degrees short of 360. So it's this angle in here, right? So what I'm after actually is the x coordinate here. So I'm after this value here. What is that x coordinate there? So I'm drawing on my associated acute angle. And my associated acute angle for 330, we're going to refer to this term a little bit, associated acute angle. So that's the AAA. My AAA for 330 is 30 degrees. It's this angle in here, the associated acute angle. If I bounce this back through all the quadrants in a symmetric fashion, like then I get this bow tie approach here, then that's my associated acute angle there, 30. Now the reason we want the associated acute angle, because if I know what the coordinates are here, then I just apply my all stations to Corio to work out whether I'm positive or negative. So for instance, what I'm saying is, let's work out what cos 30 is. And because I'm in this quadrant where cos is positive, then I know that cos 30 is going to have the same value as cos 330, because look at that, it's got the same x coordinate. So associated acute angle is 30 because it's cos. I'm in the fourth quadrant, cos 330. So therefore, cos 330 is equal to cos 30. Because this is in quadrant 4 where cos is positive. And cos 30 is, right, so now I'm thinking, oh, see, I don't even know, I've got to do, I'm going to draw this. I don't know, I don't have this in my memory what cos 30 is, I just need to see it. There's 30, there's root 3, and there's 2. So I know that this is root 3 over 2. And there's my answer, cos 330 equals root 3 over 2. All right, let's see if we can do, let's do tan 210. All right, so pause the video and work out what tan 210 is. Okay, maybe you've restarted the video now. 210. So again, I'm going, which quadrant am I in? All right, I'm now not going to draw the circle. I'm just going to go into the 210s in here, and I just want to know what my associated acute angle is. It's there, it's 30. So I'm in the third quadrant. Tan is positive in the third quadrant, so I know now that this is going to be equal to, it's going to have the same value as tan 30. So you see I'm picking up on two things here. I'm picking up on, right, that 210 to 30, that's the associated acute angle, right, that's my A. That's what I'm picking up. The other thing I'm picking up is tan in this case in the third quadrant. Tan is positive in third quadrant. They're the two things I'm picking up here. So I get tan 210, I get the associated acute angle of 30, and it's positive in the third quadrant. So it's exactly the same value as tan 30. And tan 30, back to my little triangle over here, tan 30 is equal to 1 over root 3. So tan 210 is equal to 1 over root 3. Great. Here's another one for you. Do sine 120. Sine 120 degrees. Pause the video. Okay. Sine 120. I'm in this quadrant here. I've got, that's 120 degrees there. So this angle in here, my associated acute angle is 60 degrees. So I've got an associated acute angle of 60, and I'm in the second quadrant. All stations, I'm positive again. So it's positive sine 60 degrees, and 60 is over here. 60 is just this guy in here, and that's root 3 over 2. So sine 120 is equal to sine 60, which is equal to root 3 over 2. Okay, let's do cos. Let's come over here now, and I want us to work out cos 405 degrees. Now, cos 405, now I've blown through a whole revolution here to 360, and I'm into my second lap by 45 degrees, aren't I? 45 degrees. So my associated acute angle is 45 degrees, right? Now, so it's going to be equal to cos 45 plus or minus, depending on whether it's positive in this quadrant or not, because all positive in this quadrant is equal to positive cos 45, which is 1 over root 2. Every answer's been positive so far. How disappointing. Let's hope tan negative. Oh, no. I'm going to change that one because that's also positive. All right, so let's do tan of negative 225 degrees. So have a go at that one. Okay, negative 225, I'm going around this way, 180, and keep going, and I'm 45 into this quadrant. So my associated acute angle is 45, and tan, I'm all stations. Only sine is positive here, so tan is negative. So I'm minus tan 45 degrees. Do you see the association there? The associated acute angle, positive acute, and whether tan is positive or negative in this quadrant here, the negative 225 quadrant, which is quadrant 2. Tan is negative there, so I'm at negative tan 45, which is negative 1. You can check all these solutions using your calculator. One more, let's do sine of 570 degrees. Pause the video and have a go. 570. So I'm just going through 360. All right, so I've gone through 360 there, and I'm wrapping around. Another 180 makes me 540, and there we go. I'm creeping into this quadrant on the second lap by 30 degrees. So my associated acute angle is 30. And in this quadrant, all stations 2, only tan is positive, so sine is negative. So it's the equivalent of negative sine 30, and negative sine 30, just draw that little triangle up again quickly. I kid you not, I need to do that. Sine is 1 over 2. So it's negative 1/2. Check on your calculators. Okay, and so what it's